Welcome to Chapter 12, The Biology of Learning and Memory. In this video, we'll explain the differences between short-term and long-term memory, and explain how working memory differs from both short-term and long-term memory. In 1949, Hebb differentiated between two types of memory: short-term memory, which is memory for events that have recently occurred, and long-term memory, which is memory of events from further times back. And we're going to go in, talk more about long-term memory in this chapter. So just to differentiate a little bit between short-term memory and long-term memory further, short-term memory is limited capacity. So it's got a very small capacity. And if you think, like when I talk about this in Psychology 101, I also, in addition, have a sensory register. So that's where all that information from all of our different senses is bombarding us at every given second, right? We have to either attend to that information or it's gone. There's no possibility of us remembering it. If we attend to it, it gets into short-term memory. And while that sensory registry has a huge, enormous capacity, short-term memory is limited. Because we have to be attending to it, we have to be processing that information so that hopefully we get that into long-term memory, which has a large capacity, some might say an infinite capacity. So with short-term memory, that memory is going to fade very quickly without rehearsal. So again, you have to kind of keep either repeating the information over and over again or utilizing it. Otherwise, it's going to fade. If you properly process that information and you encode it, you're going to get it into long-term memory where those memories persist without rehearsal, which is why you could have gone years without thinking about something maybe you learned in another class or back in elementary school or high school, and then all of a sudden something triggers it and you recall it, or a personal memory, something that you experienced, maybe just driving by the park, all of a sudden you remember your 10th birthday party. So for short-term memory, cues are not going to aid in the retrieval of these lost memories. So a cue is not going to help you recall it because you haven't encoded it properly. With long-term memory, these memories can be stimulated with a cue. There's something that's going to help trigger that memory trace and allow you to recall that information. So this view of memory states basically that all information enters short-term memory where the brain is going to consolidate or encode that information into long-term memory. So again, I've mentioned this a few times, this idea of consolidating or encoding that information that we are attending to. If we do it properly, it will get it into long-term memory where again, it can persist without rehearsal and can be stimulated without a cue. So what happens in the brain when a memory is consolidated? What would allow a short-term memory to get stored long-term in the brain? We're going to talk later at the end of this chapter about how there's actually changes in the brain, how the plasticity of the brain changes the way the connections look. And what do you think, what would we need for this? What's the first thing that we would need in order for this to happen? Is we need more proteins. We need protein synthesis. So you have to, in order to change the structure, the shape, the number of receptors in that synapse, we need to have protein synthesis. And let's talk also about what is memory consolidation? What are we talking about? It's how an experience becomes a long-term memory. There's actually changes in the brain that allow the stabilization of that memory. So here, for example, sensory information comes in. This would be that sensory registry that I talk about in my 101 class. Now here you have short-term memory, and you have this rehearsal, this repetition, and this is occurring at the level of the hippocampus. If we consolidate it within the hippocampus, it becomes a long-term memory. And then over time, a very long-term memory, somehow it gets to the cortex. So what happens to a memory when it's recalled? So something that you learned last week in class that you're recalling for a test, something that you did last summer that you're recalling, telling a story about it. What happens to that? And this is just kind of showing you're taking those memories that you haven't thought about in a long time and you're bringing them back up to the surface. Well, now you're thinking about those memories in the context of what's going on in the current every day. Maybe you're telling a story about what happened last summer and you're talking about it with a friend. And then they were there also and they put in their 2 cents of what they remember. Now, what do you really remember and what do you remember because your friend told you about it? So every time a memory is recalled, it can be reconsolidated. So this can strengthen or change the memory, again, by a process we're calling protein requiring protein synthesis. So just as we take information from short-term memory, get it into long-term memory, and consolidate it, every time we recall something, we reconsolidate it, and that can strengthen it, make it stronger because now we have more cues to recall it, but it can also be changed or modified again. And again, this is requiring protein synthesis and again, changing the connectivity in our brain. Now, there are problems with this short-term, long-term memory distinction. We're going to go with it for this class just because it's easy to kind of keep the discussion of what goes on in the brain simplistic. But just keep in mind that there are problems and not everyone agrees with these distinctions. For the first part, is not all rehearsed short-term memories become long-term memories. I mean, think about it. You could be sitting there using flashcards, going over terms over and over and over, and still, maybe you do okay on a test, but do you remember those, say it was last semester, do you remember those terms still? Some of you may, and some of you may not. So why you rehearse them? Why didn't they become long-term memories? Why are they there stored for, access by cues? In addition, time for the consolidation varies. So if you think about it, those flashcards for anatomy terms, those might have taken forever to try to memorize, whereas something that's emotionally significant consolidates very quickly. Now, it appears as if that happens because the emotionally significant memories consolidate quickly because of the epinephrine and cortisol that are activating the amygdala. So this is the amygdala here. Remember when we talked in the previous chapter, we mentioned that the amygdala is important in emotions. And then here's that hippocampus, and they're also very close together. So in terms of emotional memories, when you have epinephrine, you have cortisol that's released because of some sort of stimulating emotion, it makes it easier to consolidate that memory. It happens more quickly. However, remember, we also talked about that long term, that could be detrimental. So as I just said before, epinephrine and cortisol enhance the consolidation of those recent experiences and activate the amygdala and the hippocampus. So Bagley and Hitch proposed an alternative to short-term memory that they called working memory. And basically what they said was that working memory is this temporary storage of information to actively attend to it and work on it for a period of time. And the area of the brain that's important in the storage of this type of information is the prefrontal cortex. And so I've just showed you here, remember this is the frontal lobe here, and in the frontal lobe we have that prefrontal cortex. So evidence for this is that older individuals often have impairments in this working memory, and they also have decreased activity in the prefrontal cortex. So what part of the brain do we think is responsible for working memory? What did we just say on the last slide? The prefrontal cortex.